this is the kind of research platform that they want to make sure that you disseminate through. So we've basically got a dedicated team that organize events and activities and support those projects in trying to disseminate them more broadly across the UK. We've got an international role as well. We're trying to bring in international speakers and so on. But our challenge is the decarbonisation of heating and cooling, but there are other network pluses, and they include for transport, bioenergy and energy storage and so on, and our other kind of sister network pluses on the hydrogen for transport. Network pluses are for everyone. If you're not on that list, then please send me a message and I'll add your particular title into that list. So basically, they're supposed to encourage everyone to get talking about the challenges of decarbonisation of heating and cooling. And obviously, that's a very broad topic. There should be an event, whether you're an academic, a researcher, someone from industry, a social scientist, an economist, a policy maker, or involved in the funding yourself. So these kind of forums should enable you to be involved and see what's happening. Because it's funded by the UK Research Council, there's no fee to attend our events. And of course, we want, and there's no kind of membership or anything, you kind of just turn up and then you're part of the club. Okay, so this Network Plus is a partnership which has been established across Durham, Oxford, Brunel, Heriot-Watt, Leeds and Northumbria. And we were established initially with these set of partners, but this is just how we've started. We built on top of a pre-existing thermal energy network and are planning to continue to grow this and bring more people on board as partners. It's got kind of key objectives for the network. The first one is to grow a world-leading research network around the topic of thermal energy, so that we can all communicate together and let each other know what's happening. This is obviously a very timely topic at the moment. It's a big challenge. It's going to cut across residential, business, industry. It's going to be net zero relevant. So of course, lots of opportunities to be involved in a network which is going to be rapidly changing. The plan is to try and bring together lots of the different stakeholders across the technology, across end users and social scientists and policymakers. And we plan to do that through sandpits, workshops, the possibility of doing secondments, research studies and public engagement. And then of course, the key then is to try and get people from each one of those sectors to work together on different key cross-cutting challenges, and we'll try and do that through some of our flexibility funding, which we will announce how to get hold of in the near term. And then, mentioning that again, so we want to expedite the development of the state of the art and create opportunities. So this is where we've set aside some of the funding from our grant to support a flexibility fund, which will do some calls for research around in the near term, and then also it will also potentially support some secondments and travel bursaries to make sure that when we can travel to events, that no one's frozen out of that process. We have kind of set aside kind of 5 core themes that the network works around. The first is about the kind of core technologies that deliver heating and cooling, your heat pumps, etc., or gas boilers, and the key technologies and their surrounding systems for decarbonisation. And then number 2 there is the actual underpinning technologies, materials, control, retrofit, and infrastructure. So that would be potentially the equipment or the materials that underpin the primary energy technologies. We've got at a high level, we've got what's happening with the wider energy system. Obviously, that's obviously got key element related to economics. So economics is obviously a key part of that too. And then 4 and 5 there show the relation of the technology back to people, and how do you shape the future world in a policy and a leadership setting in order that we can transition to net zero with less pain, as possible. In terms of like the practical element of the Network Plus, we're planning to have activity around 4 key areas. The first one is co-organized events, and that's one of these events right now. And we plan to have many of these over the 4 years. We've been doing most of them online to date, but hopefully transitioning to real world in the near term. We have a budget for secondments, so taking an academic and getting them to work in industry for a while to solve problems in and around this challenge, and also travel bursaries to support early career researchers to go and travel to our events and activities. And as I mentioned, we've got some budget for multidisciplinary research feasibility projects. And there's also a role as well in and around roadmap development to try and explain what the key technologies in this sector are and how are they evolving, and to try and communicate that to a wider audience who are now taking an increasing interest in this particular area. So in terms of events and activities, I would highly recommend going to the Net Zero Research website, because you will find out A, when events are taking place, B, I think there's now about 30 different videos from presentations, talks and stuff that have happened over the last couple of months. They all go live, they're all recorded on there, so you can go back and look at what happened earlier this week, hopefully when Jackie's uploaded them, but also our historic activities as well. So please go on there. But you can also click and sign up for effectively a mailing list, so you'll know when activities like this are happening. And there are other platforms as well, if you're into social media, and you can also follow us through those too. But focusing now specifically on today, basically today's topic is heating and cooling sectors. It's organized into 3 parts. Session 1 will look at the challenges of the domestic and retail sectors. Professor John Counsell is from the University of Chester, and he leads us department of 8 staff and its research activities in the theme of engineering systems architecture. And this covers renewable energy systems, terahertz RF, Li-Fi communications, low voltage, remote powering, advanced control systems, UAVs, building energy systems, and local community energy systems. In this field, he manages the associated postgraduate training and research programs. The department is fully engaged with test facilities. I think Energy Centre at Thornton is the tag, and EA Technologies identically thermally matched test houses for energy systems research. So John, hopefully your microphone is working. We can see your slides.
Yes, thank you very much, Andrew. Hopefully you can hear me.
Yeah, carry on.
Okay, thank you very much. First of all, thank you, Andy and Jackie, for giving us the opportunity to speak. Just to update my profile, I've recently handed over the head of department role at Chester of our computer science and electronics electrical engineering department. And myself and Dr. Yusuf Khalid are now very much focused on building our research capacity in digital energy systems and control. Our background goes back to the University of Strathclyde, where I was the Professor of Energy Utilisation for BRE, and Dr. Khalid was my PhD student back then, funded by the BRE Trust. And before that, I probably one of the rare individuals who's worked for the electricity industry and BRE, which is I used to head up electric heating, intelligent electric heating research group at EA Technology, previously the Electricity Research Council in the 1990s, where we first introduced heat pumps into the United Kingdom. We also first introduced demand-side response into the United Kingdom. So heat pumps and demand-side response are no new things to us. I spent most of my career so far bridging between the practice of the world, the Glen Dimplexes of the world in electric heating, the utilities, electricity, EA technology, and also the requirements for building regulations and new build, which are very much driven by the standard assessment procedure, SAP, which is managed by BRE. So I very much, Yusuf and myself, very much consider ourselves to be practitioner researchers in the field of domestic heating. So we thought I'd just review some of the things we've been looking at over the years and highlight some of the challenges and where we go from here. We're currently involved with Durham University, with Professor Roskilly and Chiwe Ma on solar energy storage, which is a really exciting prospect to lock up heat in the summer and try to use it in at least the shoulder months to help decarbonise our heating. So we are involved in some blue sky work as well, and I'm very happy to be involved with Durham. I'm very excited about your network, by the way, Andy. That's very exciting indeed. So the first thing we want to really took is the agenda. I'm going to quickly go through what I've learned as consumer requirements with domestic heating, some of the challenges, and there are many. Go through some of the state-of-the-art solutions aiming at a zero carbon heating world, some of the more recent innovations and question marks on how recent they are. And then really just sort of concluding how complicated the world has suddenly become. Heating has been a relatively simple business, and suddenly it's incredibly complicated. We don't really know which way we're pointing. Are we trying to save people's lives by keeping them out of fuel poverty? Are we trying to save the planet? Are we trying to make sure the infrastructure of the country is not too expensive to support the heating system? From one day to the next, I don't really know what I'm doing. And this world is very, very complicated because none of those vectors are very well aligned. So we just want to introduce what we're doing to try to help us to navigate through the complexity. And that is a modelling environment, which we developed first at Strathclyde, called Ideas. And now we've expanded it and made it more thorough with a new method called Integrated Domestic Energy Model, IDEM, and introduced dynamic carbon analysis. I've got some results and to show you for all electric hybrid heating system we did in 2018, 2019 with BRE, and some observations and what I think next steps would be. So consumers want to be comfortable at all times. That goes without saying. But if you don't know, there's a big difference between air temperature and comfort temperature in a house. We haven't got time to go into that. But the difference between energy calculations meeting comfort temperatures, which is what human beings work on, is usually 10 to 15% higher than if you do an analysis just meeting a 21 degrees air temperature. So if you do your analysis on people being comfortable on air temperature, please go and read the CIBSE guide on comfort temperature. You're targeting the wrong thing. Consumers will do what they have to do to be comfortable. And that is really, they find the comfort. They don't find 21 degrees. They find a temperature on a thermostat that delivers the comfort temperature they want. Comfort temperature was defined by Fanger and my ex-boss, Don McIntyre, in the 60s and 70s. It's a very complicated science, but there's a simple CIBSE guide which says that your comfort is half the air temperature plus half the temperature of the surfaces that surround you. So you have to work out the temperatures of all the surfaces around you. Consumers hate high bills. That goes without saying. Consumers want reliable, low-cost maintenance systems, especially in social housing where landlords don't want maintenance at all. Really, generally speaking, we've been trying to drive to simplify the heating system, not make it more complicated. And that's unfortunately what's happening now. Consumers must feel in total control, and consumers like hot surfaces. I've often said, is that those who've been in a country house and you've been out for a freezing cold walk in the winter in the snow, there's nothing more satisfying than coming into the kitchen and sitting on an Aga. So basically, this is a wonderful experience to sit in front of hot surfaces. And renewable energy and renewable heating systems are generally low temperature. So you can see the challenges we've got. Whatever we say or whatever we try to tell consumers that it's more efficient to sometimes waste heat, they'll never believe you. So consumers are not that stupid. I've listened to government talks over the years, listening to politicians saying just if only the public was more sensible and would listen to the advice we give them, they would change from their gas boilers. But actually, that's not the case. You know, because consumers are very much focused on energy efficiency. And consumers have actually increased their household efficiency overall from 79% to 84% in the last 7 or 8 years just by switching to LED lighting. So they're not so crazy. And as Margaret Thatcher famously said, you cannot buck the market. The market isn't so stupid. However, what is the elephant in the room? You'll see that I've managed to find a picture that coordinates the wallpaper with my slide design. But the elephant in the room is that things are changing. And really what's happening is, as we've reduced electricity demand by nearly 30% off the national grid, and we've introduced more renewables in wind and PV, then the carbon intensity of the grid has reduced quite significantly in the last 10 years. And we've reached a point where the carbon intensity of the electricity grid is virtually the same as the carbon intensity of a gas condensing boiler. So it was once carbon efficient, to switch an incandescent light bulb over into an LED light bulb. And we did this by once putting typically 60 watts into the incandescent and getting 59 watts of heat out. And that 59 watts of heat was 59 watts of heat that you didn't need to find from your gas boiler. Now we only get 3 watts. So we now need to find all that heat. Typically, we need to find 56 watts extra heat from the gas boiler. But the gas boiler is no more carbon intensive than the electricity. So actually, putting in LED light bulbs now is a bad thing for carbon. And that's all happened in 10 years. So you can see what I mean when I say the world is getting very complicated. We don't really know which way to turn. What are we seeing right now in solutions? Well, for low carbon solutions, we're seeing a drive to switch gas boilers, condensing boilers, over to a mix of hydrogen. And we think we will see a big push from the gas boilers for that. Electric storage heaters. Well, if you talk to the government, they will tell you they're terrible things. That's because most of the people that are advising them are even older than me and remember the early 1970s storage heaters, which were terrible things. But new storage heaters, high retention insulation using space shuttle type insulation, are incredibly controllable devices, and their ability to store low carbon heat in off-peak times shouldn't be underestimated in a demand-side response world as we go forward. Direct electric heaters, they're not going anywhere. You know, if you'd go to a SAP 10.1 calculation, which is the latest new building regs, then and you put in a 1 and 2 bedroom flat, the highest levels of insulation, your energy consumption from your domestic hot water is nearly twice that of your space heating. So are you going to really spend £10,000 on a heat pump when really you're using very little heat? So direct electric is going to stay with us. And there has been some quite innovations in trying to create higher surface area heating with graphene mats under the laminate flooring and carpet, and also enhanced fins on a kind of ceramic heater to make better comfort from panel heaters. So one of the problems with convector heaters is all the heat ends up on the ceiling. We're also seeing emerging, well, micro CHP is not emerging. The late Ray Winstanley introduced micro CHP into the UK in 1989, and I joined him in 1992 with the Swedish in Malmo to look at the first engine that we were going to bring to the UK. That's now the Whispergen type technology, and also organic Rankine cycles have been developed. Perhaps moving over to hydrogen with micro CHP will bring a technology to be reborn. We're seeing fuel cells. Fuel cells, again, are not really a new technology, but hydrogen fuel cells, natural gas fuel cells are still being developed by many universities, and we're very well aware of Imperial's activities in that. As I think they were one of the most successful impact stories in the last REF round. And of course, finally, our beloved heat pumps. Heat pumps have been with us since the 1950s. Jack Sivier, who worked for me at EA Technology, carried out the first heat pump trial in the UK that I'm aware of in 1987. We carried out the largest heat pump trial until recent years in 1995, and there were significant problems with heat pumps. Some have been overcome and some haven't. So innovations now I'm seeing, what's happening now is the word hybrid. We've got hybrid vehicles, now we've got hybrid cars. So what we're now going to see is more and more hybrid heating. So we're going to see solar heating added to gas condensing boilers, possibly with hydrogen. We're going to see gas boilers integrated into heat pumps. Valent has already done this. It's been tested at BRE. I saw that about 18 months ago. Simple systems, which are a real threat because people like simple systems, especially landlords and flats. So, you know, PV on the roof, Tesla battery, the Tesla Powerwall battery could take low carbon electricity from the grid at off-peak times and just use a simple low cost panel heater to heat the house. This is an alternative to heat pumps and is no more expensive and is falling in price daily by following Moore's law. Ourselves and Yusuf, Dr. Khalid and myself, we worked with BRE, Glendimplex, to develop a different type of hybrid system where we took the principle of the GEC Night Store, a dirty great big storage heater which could heat hot water that was used in the 1970s, and made a micro version which we called the quantum boiler. Working with the domestic hot water tank, we were able to create a system we called RISE, which allowed us to control heat pumps and off-peak storage, thermal storage, to mix and match to try and meet the multi-objectives of thermal comfort and carbon minimization. Very challenging problem is trying to meet two objectives at once. So the complexity of all these systems, which is best? Well, it depends on your metric. This week, Boris wants to save the planet. Next week, he might want to save pensioners. I don't know. It's anybody's guess. So the metrics are changing all the time. Part L building regulations, the metric there is actually primary energy. Some of you may not have heard of that. Primary energy is what has been proposed for Part L building regulations, but it's been in consultation for nearly 6 years and it's not decided yet. So you can see that we've got some major problems trying to decide what's most important. People's lives or carbon dioxide. How do we meet those two challenges? So from my point of view, we need some a way to model and evaluate the true performance of real systems. And that's what we've been doing at Chester, carrying on from our work ideas that we did at Strathclyde. Ideas, I worked with Brian Anderson, the inventor of SAP Part L building regs, sadly passed away a couple of years ago. And we calibrated our dynamic model with SAP, and we've recently expanded it in its thoroughness to include non-linearity and all the complexities of real non-linear behavior in the thermodynamics of a home. And you can see that if you're ever going to try and calibrate a model with building regulations, statistical data, remember, it's not just about energy. You also have to calibrate temperature. And that temperature is not an air temperature, it's a thermal comfort temperature. We can produce these results. This is a typical Sheffield house, which we use to calibrate SAP. And these are the kind of dynamic responses we get. The black line is an optimum start that you need to meet the red line, which is the SAP target comfort temperature. We use a principle of inverse dynamics in our dynamics to make sure that the requirements of building regulations are always met, however complex the system may be. We've also introduced dynamic carbon. It's very important that you look at the true carbon intensity of your solution. There's no point using an average carbon for winter analysis, because on the national grid, the carbon intensity is much higher in the winter than it is in the summer. So if you're going to use a heat pump for space heating and that you're going to use an average carbon intensity, well, frankly speaking, you're cheating because you're benefiting from a low carbon intensity in the summer when you're not using it. If you're using it for domestic hot water, it's probably not too bad. But space heating carbon savings from heat pumps, when I see them, they're usually very wrong. We tested a RISE system in the Prince Trust House at BRE. These were typically our modelling results. We could compare the dynamic temperature response for an air source heat pump in the winter and the summer by validating the model. Our RISE system wasn't very good. Our storage system hadn't got the capacity to maintain comfort. It also wasn't so good at controlling the temperature in the summer, because thermal storage in the summer and shoulder months causes problems. So the air source heat pump, however, isn't that good either compared to a gas boiler. That's something else we learned. What's very important is that when you're doing these analyses is you look for the truth. And if you do a dynamic carbon analysis, you can see that with an air source heat pump, there's a 17% difference in the carbon emissions with space heating from using a true dynamic carbon analysis compared to doing a static one. And you need a dynamic model to be able to work that out. So there's a few conclusions you can read there later. So in summary, we're living in a world of complexity, serious complexity. We need a modeling method to be able to understand what metrics are best and how best to meet them. There's no silver bullet in getting towards zero carbon heating. There are likely to be different sectors have different solutions. Hybrid is the new word, and we're going to see more and more hybrid systems. But I feel that what we'll see is more zoning. We won't see fully integrated systems. We might see upstairs, downstairs solutions, different solutions for domestic hot water and different solutions for space heating. One of our greatest and single biggest challenges is within the last few years, the rule of thumb that gas is 3 times cheaper than electricity has been broken. Currently, electricity is nearly 5 times the price of gas. I wonder where this is going to stop. Are we going to end up with 6 to 7 times the price of gas for electricity, in which case any chance of electric heating in our society is dead, well and truly dead? There is no way that we will be able to put so many people into fuel poverty. We will be taking ourselves back to the 1970s, where there were as many people dying and suffering from fuel poverty as they are from COVID-19 today. We cannot go back. In short, I feel that hybrid gas solar boilers and hybrid electric PV heating with low carbon domestic hot water solutions will prevail in the short term. And I very much welcome and would welcome to work with more and more with my academic colleagues across the country to share our experiences in industry over the last 30 years. Now that I'm an academic with a bit more freedom, I'd be delighted to help. And USAF's contribution here is fundamentally we have to get people to love a low carbon life. And that cannot be underestimated as a challenge. Sorry, Andy, I'm rushed through there.
Thank you very much,
I have a lot
John.
to say, and hopefully I'm not overrun too much.
Thank you. No, we're okay. I think, so thanks so much, John. I think John will now stick around for a while. The next speaker, Alex Pitman. Alex is Carbon and Energy Performance Manager with the Co-op. He's previously worked for Business Wise Solution and Commercial Director for BCM Limited, specializing in the design consultancy services for energy efficient buildings. So Alex, please take it away.
Okay, well, we've done the difficult bit already then, so yeah, we'll see how it goes from here. So yeah, I thought on our sort of journey towards lower carbon heating and cooling solutions, what I wanted to do today was sort of share some of the problems from a retailer perspective and the progress so far and what we're doing next. So just as we said, look after energy and carbon management for Co-op Group. For those who don't know, we're a mutually owned, member-owned group, over 150 years old now, and we look after about 4,000 buildings around the UK. So we've got quite a big energy bill ourselves, it's going to be about 80 million this year. So energy is quite an important cost for us. As part of that, we've developed a business within the Co-op Group called Co-op Power, rather sensibly. So, and then we look after energy and carbon services outside the Co-op as well. So we got a collective buying solution for buying renewables that we started. So we work with organisations from National Trust to Road Chef to Nationwide Building Society, all getting together and buying energy. So we do end up looking after some sort of weird and wonderful variety of building types, but sort of heritages in retail. So that's what I'm going to talk about today. So yeah, so I'm just going to run through where we are on our carbon journey, the sort of targets the Co-op set, but also typically across the retailers, and then talk about some of the challenges and potential solutions and stuff you could help me with. So Co-op is a good example, but all the major retailers have set similar things. We've been talking about energy and carbon for a while. We've been reporting and disclosing it quite a few years. And so we report that as grid average. So we've been reporting for a while and we've made some good progress. So like I said, we spend a lot of money on all this stuff. And of our carbon emissions, most of it is electricity and gas. And then in common with lots of retailers, a surprising amount is actually leakage of refrigerants. So our F-gas emissions are a pretty scary number. So numbers on the left are our total scope 1 and 2 emissions for last year. And then of that, heating and cooling, of which fridges is the biggest element for us, is some pretty big numbers. And of course, we're keeping stuff cold on lorries as well as driving them around. So that's the sort of scale of the problem for us as a retailer. And is a fairly similar numbers across all the big food retailers in the country. It's a little bit different for the non-food retailers, but heating and cooling a big thing for us, particularly as we've all set net zero targets. So
as an industry, we've come together, British Retail Consortium, and all signed up to net zero targets by 2030. All retailers got individual targets and individual roadmaps to get there, but we're all heading towards a flavour of zero carbon. Lots of work going on across the industry on defining the different flavours of zero, but as a direction, that's where we're all trying to get to. And it's what our consumers and customers and other stakeholders are asking for. So in the Co-op's case, because we're a democratic organisation, we have a motion every year on the AGM about go faster on climate change. So so that's where we're all trying to get to. So key challenges, I already mentioned the F-gases is an enormous number, and we're moving towards that, partly driven by legislation. We're on a journey that's going to get rid of F-gases. And if we combine that with good renewable power, then we're moving towards a lower carbon solution on lots of our cooling. There's lots more we could do. So roughly supermarket fridges use 1% of UK energy consumption, and most of the fridges don't have doors on. So while we've set encouraging targets and across the industry, it's not super impressive the progress we're making as a collective. So there's lots more relatively low tech opportunities. And then the picture on the right is from New York, where they've got local building regulations around keeping doors closed when air conditioning's on. The good news is I've actually got a door to close. If you wander down Oxford Street at the moment, there's a reasonable amount of retail sites that don't have front doors. They've removed the front of shops. So while there's some sort of cutting edge and innovation stuff we need to do, there are some, the good news is there's some pretty good opportunities without having to be too clever. And we've also got opportunities to reduce demand. Do we actually need all things cooled to the temperature they are, etc. And then energy effectiveness is our sort of term for energy efficiency, sort of using less, but also using it at the right time. So building on some of those earlier slides around carbon intensity, being smart about when we're using energy is quite important. So big picture there, some of the key things on cooling. And then on heating, basically around getting rid of gas. Saying earlier around what are our options around heat pumps. With all the different zero carbon standards, we're trying to understand exactly how fast we need to get rid of gas and what's the role of offsetting and all of those things. But basically, we're on a trajectory where most retailers are trying to get rid of gas, which leads us to heat pumps as a absolutely key technology. And we've been doing these for a number of years, and it's complicated exactly how to deploy this in sites with lots of fridges. But basically, we're finding if we get the building insulation right, so we're reducing the demand, and as I mentioned earlier, the coefficient of performance versus electricity price is an absolutely key ratio for us. What we've learned is when we do the analysis of energy prices against coefficient performance, the key thing is exactly when we're using it in the time of day, because electricity prices are quite complex things. So if we can add a little bit of storage just within day storage and use electricity at the right time, it has big implications. So we're doing some work on the energy retailing side of our business and trying to get the right smart tariffs to help people. The other option, which is around there, which was mentioned earlier as well, is hydrogen. A number of retail colleagues have been looking at this. The sort of challenges really are around speed and price. So how quickly is this thing going to turn up? How cheap is it going to be? And like that is exactly which colour carbon are we talking, colour hydrogen are we talking about, and how sustainable is that? But we've probably got further to go on heating than we have on cooling as an industry. And it's absolutely crucial for the non-food retailers because that's where most of their carbon emissions are. I mentioned a few themes there, and I'll just a few graphs which I'll try and join together. So, rightly mentioned the different carbon intensity within seasons is also very different within days. So this is this week's carbon intensity and the carbon forecast. And we've seen some really low carbon figures, like over Easter, when industrial demand drops off and it was sunny and windy, but then it shoots up at other times. As we can see this a few days ahead, being able to plan when we use electricity at which carbon intensity, smart opportunities there. And then if we look at how this works on a grid level, not only does it have carbon impacts, but balancing requirements. So if someone in National Grid says, help, what can we do at local level to do the demand side response? So most retailers are doing something on large sites like cold storage and big distribution centres, and maybe data centres where they've got generators. Or the markets are changing quite rapidly there. Relatively few have deployed this at smaller store level, but there's this area is going to grow rapidly. So there's as well as the carbon intensity, there's a balancing requirement, and then there's a commercial imperative as well. So with this imbalance of the grid coming along, we can see the amount of time when electricity is going to be really expensive or basically free is increasing all the time as well. So, and I think we've seen some of these trends in other energy markets around Europe where they've got more renewables. So this is quite an important angle as well. So the value of flexibility in pound notes is looks like it's increasing. And then hydrogen pathway. So looking at the modelling work which has been done by the national gas grids, they're assuming hydrogen is coming, but it's relatively slow before it becomes a significant part of the national grid. So versus most retailers' targets, and I think the climate science is telling us this is relatively slow as a solution. I know there's lots of talk about hydrogen, but based on that graph, most retailers are thinking, oh, we need to do something else. And then also from sort of modelling work of the green hydrogen, quite intriguing idea, and is that going to play a part in balancing grid, and how does all that work in the future? But most of the forecasts I've seen is green hydrogen is going to be a relatively small part of the grid. So there's some retailers who are interested in, or could we get the nice green hydrogen and use that in our mix? But it's relatively small numbers, even at the end in quite a few years. So joining those four graphs up, really, where we think one of the key opportunities is doing something smart with heat pumps quite quickly. So if we can combine reducing demand with the right phasing and storage solutions, have a heat pump with no HFCs, stick some good quality renewables in it, so you're paying the right sort of prices, and make it upgradable so we can do new things. This is quite looking to do this. We've got other things we want to do with the supply capacity as well. So most retail sites will be trying to get electric vehicle strategy in there as well. Something that joins together all these electrical capacity requirements at building level is going to be part of our challenge. So I think we've got nearly all the bits of the jigsaw there, and commercially it's starting to make sense. It's not simple yet and completely packaged in exactly the right way. So we're going to need some more innovation and joining up. But I think that's a key opportunity for the sector. And then beyond that, really, we need to do some wider action on carbon, which is part of the reason Co-op Power was created. So we're working with all these partners to try and come up with more low carbon solutions and do collective action and buy things together. We've started to push targets down the co-op supply chain, as many other retailers have. So we're setting carbon targets people are supplying us. And then we just need to work with more partners to drive some innovation and change. That was it for me.